So hello everybody. So everyone, today's target is doubt clearing class on limit. Okay. So I'll call you one by one and तुम लोग यहाँ पे आओगे and answer दोगे. ठीक है ना? First of all, how to solve this sum? Limit x tend to 0 x to the power x. How to solve this sum? How to solve this sum? Anyone can tell? First of all, I will tell. Yes, right. First of all, we'll treat this as the y. Okay. So y equal to x to the power x. So log y equal to x log x. But there is a problem which I told you in the last time. There is a problem in this case. You tell me, is the limit valid? Because limit x tend to 0, you tell me, limit x tend to 0, okay? So, what is the meaning of limit? When left hand limit, when limit x tend to a, left hand limit equal to limit x tend to a plus right hand limit, when they are equal, we can say that the limit exists. But remember one thing, limit x tend to 0 minus. It's a big problem, everyone. Limit x tend to 0 minus. 0 means 0 plus 0 minus. Limit x tend to 0 minus, limit does not exist. So what to do? Is it true? Is it right? It means limit does not exist. Then what to do? Who will tell here? Come and tell. You come here and tell. You come here. Come on. Come first. Recording is going on. Come on first. See you. Tell me, is the limit right?
No. Limit x 0 minus
It
is.
means the sum is right or wrong? You tell me.
But here will be 0 minus.
No, actually original sum is 0.
Okay.
So if it is 0 minus, then the already limit does not exist. Understand this? Okay. So the thing is that this sum is wrong or right? My question is this. Tell me.
Sum is right.
Because
there are two cases, x tends to 0 minus and x tends to 0 plus.
x tend to 0 का मतलब ही तो 0 plus and 0 minus. But the thing is that we have given x tend to 0. According to you, then the sum should be wrong.
Yes.
You very carefully see this. Understand this. Anyone will tell anything? Have a look. If x is simply, I am telling you everybody, if the limit x tend to 0 minus, x tend to 0 का मतलब 0 plus and 0 minus. When x tend to 0 plus, the log is okay. When x tend to 0 minus, limit does not exist. But here limit exists. Because from outside I have taken limit, log. Okay? Originality it was not log. Right? Therefore this limit exists. Now what will you do? So in this case, it is in the form of what? X tend to 0. This is 0 into infinity form. This is 0 into infinity form. We cannot apply the L'Hopital's theory. L'Hopital's theory will be applied when it is either 0 by 0 or infinity by infinity format. Right? Therefore, we can say here log x by 1 by x. Okay? Is there anyone who can solve at this moment now? Anyone can solve now? Come here and solve. Solve it. Log x is 1 by x minus 1 by x square. Where is he? So it is x. This is x only. What is going on? This is x only. Minus x actually. When x tend to 0, therefore log y, this is y now, log y equal to, yes right, log y equal to 0, y equal to e to the power 0 means 1. Very good. You have understood the thing, everybody? It means, everyone, originality you have to see. We can take sine inverse, we can take sine, we can take log, whatever we can take. Okay, that is a derived. But remember one thing, this originality doesn't matter. Concept is okay? Acha, everybody. Third line, this is a derivative. Log x a derivative 1 by x, or 1 by x ka derivative minus 1 by x square, and take it up. 1 by x cancelled, and log y equal to 0. This is. So, bolo? 1 minute. 1 minute. Let me clear some concept. Limit x tend to 0 tan of fractional x. Everybody fractional x. How to solve this sum? Root over tan of fractional x. How to solve this sum? Acha. Whenever, remember one thing, whenever it is related to the limit, so we have to see left hand limit equal to right hand limit. Okay, clear your concept. So when limit x tend to 0 plus, let x equal to 0 plus h, therefore as x tend to 0, h tend to 0, we have to do like this. So we can write this as root over of tan 0 plus h, fractional h. Everyone, regarding the fractional curve, see one thing, this is the fractional x ka curve. When x tend to 0 plus, then to h tend to 0, this is h. Remember this for fractional x. Okay, regularly questions are coming on this. So we can write this as limit h tend to 0, root over of tan h. Acha. One more thing, everybody, or x. When regarding h, in case of limit, one very important thing I am telling you. Regarding h, okay, this h is a positive quantity. It is not h plus 0 minus, because I have taken already x equal to 0 plus h. This h is a positive quantity. Remember this, it is called pre-assigned positive quantity. Whatever you think, it is lesser than that. Whatever you think, it is lesser than that. Okay? So this is tan 0, 0. Any clarification? Anyone will tell anything? Now, if I tell you limit x tend to 0 minus root over of tan fractional x. So Aishwani can tell me x equal to 0 minus h. Fractional minus h क्या होगा? I told you everything. Your target was something, na? So tell me. No? Tu bolo? Obviously, fractional minus h means 1 minus fractional h. It means 1 minus h. Why it is? What is the reason behind it? Just see, when anything is lesser than 0, this portion, anything is lesser than 0, so this curve is y equal to mx plus c. It means this is 1 plus y equal to mx plus c. So here, so this is coming 1 minus h. Okay, therefore we can write this as limit x tend to 0 minus, it's मतलब x equal to 0 minus h, as x tend to 0, this is x tend to 0, so h tend to 0. I am writing here limit h tend to 0, tan of 1 minus h. Now h equal to 0, root over of tan 1. This limit exists. Everybody, limit does not exist. This is the right hand limit, this is the left hand limit. Okay? You have understood the thing? Everybody? Any question, any comment on this? On the basis of this, we'll do the class in the next day. You tell me, you ask your question. That I will not tell you at this moment. It was your homework. Or this is the YouTube live is going on. Tell me something different regarding this class. Acha, everybody, one more thing. One more thing I am clearing you. These are regularly coming in JEE examination. 1 minus cos 2x by x. Limit x tend to 0. What to do? Try to solve it. It was your homework, and whatever question I have given you, you should not ask me. Bolo. Who can solve this sum? I am showing you. See this everybody? Mod box fraction root. Okay? So for these functions, we have to solve the sum carefully. See this. In this case, limit x tend to 0, 1 minus cos 2x is 2 sin square x. That is 2 sin square x by x. Everybody see this. Regularly this type of questions are coming in examination. Limit x tend to 0. Anyone can tell, anyone will come and write the next stage? Will you come here? What is the next step? Come here. Just next step you write me. Maybe. Write the next step. What is the next step? Just you write. Root over. Acha. Just only one x is here. Acha. Okay, fine. Everybody, this is very important fact. Remember this. Just I am changing this. See this? In this case, in this particular case, root over of x square का क्या मतलब? Mod x. Remember this. Root over of x square is mod x. Okay? Because we don't know whether x is positive or negative. So we are applying mod. So in this case, we can write this. Limit x tend to 0, root 2 mod of sin x by x. Mod of sin x by x. Remember this, whenever root over is there, mod of sin x by x. Okay? So generally, I tell my students that whenever you see the mod, in 99% cases, it does not exist. But that is a different issue. But the thing is that, now see, when x tend to 0 plus, what will do? What is coming? Limit x tend to 0 plus? Positive. Sin x is positive. So, root 2 sin x by x, answer is coming root 2. When limit x tend to 0 minus, mod of sin x is coming negative, because what is the reason behind it? Minus root 2. Obviously, limit to does not exist, that is okay. But whenever mod related question is there, we have to do like this. So, any understanding? We have understood the thing? Sure. You can explain here. Come on, come here and explain. Come on. Come on first.
Sir,
Explain from the beginning. This is okay. This step is okay. Then root over of x square is mod x. This step is okay. When x tends to 0 plus, you have understood?
yes, sir. When x tends to 0 plus, there will be sin x by x equals to 1.
Okay.
So the answer will be root 2.
Okay.
But when x tends to 0 minus, sin x will be negative. So there will be minus root.
Can you tell me why? There's a lot of confusion of the students regarding the x tend to 0 minus. Why mod is coming negative? Can you tell me? What is the reason behind it? The thing is that, just see how you are afraid of this. So just see one thing. When x tend to 0, mod x का definition, when x tend to 0 plus greater than equal to 0, this is positive. And this is negative, understand this properly. When x is less than 0, because x itself is the negative, right? To compare, but we need the positive. X itself is negative, but we need the positive. So to compensate this negative, one extra negative is imposed here. You have understood the thing?
Yes.
Here sin nije negative, sin itself is negative, but to compensate, but we need the positive quantity. What a positive? So to compensate this sign, we need some extra negative. You have understood this? Sure. Thank you. Next. Concept is okay, everybody? Mod x concept. Any clarification? Can you explain, Anisha, to her? You explain once. Total clear? Matter is okay? Limit x tend to 0. Limit x tend to 0 box x. What is the meaning of this? Limit x tend to 0 box x, what to do? Anyone can tell? Total, let us clear our basic concept today. Limit x tend to 0 box x. What should be the answer? Who can tell this? हाँ बोलो. हाँ. When x tend to 0 plus everyone, this is the curve of box x. X tend to 0 plus 1 is nearer 0. So this is coming 0. When x tend to 0 minus, follow, it is minus 1. So limit does not exist. Left hand limit equal to right hand. But remember one thing, if the question is coming, what is the jump of the function? What is the jump? क्या मतलब? Jump of the function का क्या मतलब? तुम लेफ्ट में हो, तुमको राइट में जाना है. कैसे, कितना जंप देना होगा तुमको? तुम नीचे हो, यहाँ पे हो. One jump. So jump of the function is 1. Concept clear? Bigger value minus of lower value is the jump. Total concept is okay. Next. I am changing. Limit x tend to 0. X sin 1 by x. What will be this? Very basic concept I am clearing everybody. Who can tell this? Tell me. 1. Why? Sin 1 by x by 1 by x is what? Okay, okay. So everybody, lot of students are making this mistake. See this. Limit x tend to 0. Maximum students are telling like this. Limit x tend to 0. See this. Sin 1 by x by 1 by x equal to 1. It is totally wrong. Can you tell me why it is wrong? X tend to 0. Original formula, x tend to 0 sin x by x equal to 1. 0 by 0 form. Is it 0 by 0 form? One more. Clear it. Okay? A common mistake. So maximum students ऐसा mistake करते हैं. So what we will do? I am telling you the answer of this question. X is tending towards 0. Positive or negative does not matter. X is tending towards 0. Okay? Whatever may be, this is a finite quantity. Sin 1 by x lying between minus 1 and plus 1. X so not exactly 0. Sin 1 by x is lying between minus 1 and plus 1. But the limit is 0 because 0 into a finite number lies between minus 1 and plus 1. That is 0. See this. See this, I am waiting. Any clarification, anyone? Let's clear your all common mistake, common doubt. Okay, I'll continue. One more sum. One more very important formula. Limit x tend to 0, 1 plus x whole to the power 1 by x equal to e, and limit x, same formula, 1 x tend to infinity, 1 plus 1 by x whole to the power x equal to e. Same thing, same thing. This is 1 to the power infinity form. See this? When x is 0, 1 by x is infinity. The formation is 1 to the power infinity. Okay? So we can write here limit x tend to 0 or infinity, whatever, 1 plus fx whole to the power gx is e to the power fx into gx, where fx tend to 0, gx tend to infinity. We have done this in the last. Today I'll clear your doubt and problem. All these things we have done in the last day. Okay? Limit n tend to infinity, 3 to the power n plus 5 to the power n plus 7 to the power n whole to the power 1 by n. What to do? Think and tell me. Will you solve the sum? Will you solve the sum on the board? Okay. You. Look, I am solving the sum for you. See, don't waste your time. It's a doubt clearing class. I am clearing the doubt. First of all, in this type of cases, I am taking the big out. There may be another lot of such numbers. I am taking this now. I am taking this biggest outside. If I take 7 to the power n outside, it is coming out as 7. 7. It is coming out as 7. ठीक है ना? So I am writing here limit n tend to infinity 7. So this is coming as 3 by 7 whole to the power n. This is coming as 5 by 7 whole to the power n. This is coming as 7 by 7 का मतलब 1 whole to the power n माने 1. 3 by 7 is a fraction. See this everybody. We have done all these things in the last day. Just you understand everyone. 3 by 7 is a fraction. Fraction to the power infinity का होगा? 5 by 7 is a fraction. Fraction to the power infinity 0. 1 to the power anything is 1. It means 7 into 1, that is 7 over. See and understand? See and understand everybody. One more sum let us solve. It's getting recorded. Why? Let's solve the sum. Okay. I'm changing it. One more sum we have done in the last day. That is limit x tend to 0, 1 to the power x plus 2 to the power x, 1 to the power x plus 2 to the power x plus 3 to the power x, continuation n to the power x, total divided by n whole to the power a by x. How to solve this sum? Sir, bolo? By saying the sum, you can say anything. Come here and tell. Come on. Why? Formation. Come on here. Come on. Finish. What is your target? What is your target?
ISI.
जोर से बोलो.
ISI.
ISI. तो बोलो. जब by seeing the sum. You will take out the n outside. कैसे? But denominator में तो एक n है. No. First of all, we have to see the formation. It is under what form? अच्छा से देखो. If we put x equal to 0, x को 0 put करके देखो तो 1 to the power 0 क्या होगा? 1, 2 to the power 0, 3 to the power 0, 8 to the power 0, 1. कितना 1 है यहाँ पे? n1. n by n क्या होगा? x 0. कल 1 to the power infinity फॉर्म, इससे मतलब तुमको लिमिट करना पड़ेगा. ठीक है? ये लिमिट का सम. क्लियर हुआ? थैंक यू. बेटर. So everybody, see this. See everybody, I am solving the sum. First of all, it is in the form of 1 to the power infinity. So I'm adding 1, balancing 1. Okay? So 1 plus fx whole to the power gx form. Once more thing, everybody. 1 plus fx whole to the power gx, fx tend to 0, gx tend to infinity. अच्छा से देखो, fx, this portion is fx. fx tend to 0 because this is n by n 1, 1 minus 1, 0. ठीक है ना? And gx, x, so x is here. This gx tend to infinity. So we can apply e to the power fx into gx. See everybody, see one thing. Now we can do like this. Limit, I am writing here. Limit x tend to 0, e to the power 1 to the power x plus 2 to the power x plus 3 to the power x dot 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 n to the power x total divided by n minus 1 into a by x. See, any clarification, understanding problem? Just everybody, if you can do properly, you must get the result. Which portion? Who can explain here? You can explain the sum, this step. Come on, come here and explain. Come on. Come on here. Come here and explain. Come on. Don't talk. Come on. Come and explain. Come on, come here. Cannot. Who can explain more? Achha, okay, I am explaining. First of all, once again. So the thing is that 1 plus fx whole to the power gx, fx tend to 0, gx tend to infinity, 1 to the power infinity का form, so fx gx e to the power fx gx का form. So e to the power fx into gx. Now I am doing the LCM on this. So 1 to the power, everybody carefully see this step. Don't copy. It is getting recorded, so don't copy. Understand this here. A by x. So n, we can distribute the n like this: 1 to the power x minus 1 plus 2 to the power x minus 1 plus 3 to the power x minus 1 dot 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 n to the power x minus 1. I am distributing the n overall divided by, I am divided by x here, x. Now this n, take it out. Outside we have a by n. You have understood the thing? You have understood the thing? 1 to the power x, there are n number of 1. I am distributing the 1. 1 to the power x minus 1. This x I am taking inside and n is outside. Because we have to apply this part, limit x tend to 0, a to the power x minus 1 by x equal to log a. Okay? Therefore, we can write this as e to the power, this is log 1 plus log 2 plus log 3 dot 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 log n into a by n. That is e to the power log of 1 into 2 into 3 up to n into a by n. That is log of n factorial. So log n factorial whole to the power a by n, that is coming n factorial whole to the power a by n. Sum is over. You have understood? Aishwani, you have understood? You sure? Come and explain here. Just stepping explain करो. Very good. करो. हाँ? No. हिंदी में बोलो, इंग्लिश में बोलो. जोर से.
सबसे पहले हमने यहाँ पे 1 plus fx to the power gx के फॉर्म में लाया है. Then -1 तक यहाँ पर -1 तो हमने in
इंग्लिश में बात करो. इंग्लिश में बोलो.
we have subtracted this by.
Okay. अच्छा, from this step to this step. बोलो. From this step to this step, how did you get?
We have distributed the n into 1 into n form and then subtracted in every.
Okay. Then e to the power, this portion you have understood. E to the power log x equal to x. ठीक है ना? Everybody understood this? Sure? Sure तो? Thank you very much. Yes, better. So all these are the doubt for you. One more sum. In the last day, everybody, one sum we are done. Limit, right everyone? One very good sum we are done in the last day. Limit x tend to infinity. Limit x tend to infinity. This is the doubt of number of students. X sec inverse x by x plus 1. How to solve this sum? How to solve this sum? See this everyone. First of all, sec inverse x. Generally, what students will do? See this. First of all, this equal to theta. So sec theta equal to x by x plus 1. I am dividing by x. So 1 by 1 plus 1 by x equal to sec theta. When x tend to infinity, 1 by x tend to what? 0. So sec theta equal to 1. Sec theta, if there is a problem in moving with the sec theta, so cos theta equal to 1. थीटा कितना होगा? थीटा क्या होगा? cos theta equal to 1, theta equal to 0. इसका मतलब answer should be coming 0, right ना? Sure तो? No, it's wrong. It's wrong because it's wrong method. The reason is that, see everybody how to solve this sum. How, anyone will tell anything? How to solve this sum? X tend to infinity. Understand, x tend to infinity. It's मतलब x is some real number but before infinity. ठीक है ना? So x plus 1 somehow is more than x. Do you believe this? So x by x, whatever, how much large it is, but x plus 1 is more than x surely. ठीक है ना? This is a fraction. Sec inverse fraction possible na. Sec inverse fraction possible na. So everybody, this does not exist. Any question, anyone? One more sum we had done in the last time. Limit x tend to pi by 2, 1 to the power 1 by cos square x plus 2 to the power 1 by cos square x plus 3 to the power 1 by cos square x dot n to the power 1 by cos square x whole to the power cos square x. Cos square x. How to solve this sum? We have all the sums we have done. I am just solving our previous sums which was doubt for you. बोलो. Solve करोगे यहाँ पे? आओ solve करो. Come on. No, इसको पकड़ के करो. Solve करो. Solve the sum. अच्छा, you have taken just you have taken cos square you have taken cos square x. You have taken 1 by cos square x equal to t. X tend to pi by 2, ताले t tend to
0.
infinity.
Infinity, sorry.
T tend to infinity. यहाँ पे देखो t tend to infinity. Limit t tend to infinity. No, thank you very much. Thank you very much for solving the sum. See this everybody? Here, from this step, limit t tend to infinity. So same as this sum, 3 to the power n plus 5 to the power n plus 7 to the power n, that type. Tale 1 to the power t, once again I am writing this step, 2 to the power n plus 3 to the power n dot n to the power t whole to the power 1 by t, since power is t. So if I take outside n, obviously n is the biggest number out of this. So if I take n outside, we are getting 1 by n whole to the power t plus 2 by n whole to the power t dot n by n ka matlab 1, this is 1 to the power t. So all are fraction is 0, 1 to the power anything is 1. It's ka matlab n into 1, that is coming in. Sum is over. Sum is over. One more sum was the doubt for you. One more sum, let us clear it. That is, I am changing this, okay? One more sum, that is coming limit n tend to infinity, okay? n square x to the power 1 by n minus x to the power 1 by n plus 1, where x is greater than 0. How to solve this sum? All the sums you have done in the last day, so not required to write the sums. You understand this. Is there anyone who can solve the sum? Try for 1 minute, I am waiting. Anyone can solve here? See this, I am solving the sum once again. And lastly, the sums which were done in the last time. So few students could solve the sum in our batch. That sum I will solve, but must understand. First of all, for this, limit n tend to infinity, I am taking, understand this properly. Formula limit x tend to 0 a to the power x minus 1 by x equal to log a. This formula will apply. We'll apply this formula. You know this formula, Ayushman? Ayushman, you know this formula? You don't know this formula, right? So, I am taking x to the power n plus 1, n square, x to the power n minus n plus 1 minus 1. Any clarification? I am taking x to the power 1 by n plus 1 out. Therefore, limit n tend to infinity 1 by x to the power 1 by n plus 1 into n square. If we do the LCM of this, x to the power 1 by n into n plus 1 minus 1. In the product form, we can apply the limit directly. If n tend to infinity, 1 by infinity is 0, x to the power 0 ka matlab 1. Okay, so I am applying here limit n tend to infinity. So x to the power 1 by n into n plus 1 minus 1 by 1 by n into n plus 1 balance by 1 by n into n plus 1. ठीक है ना? Divide by, this is n square is out here. So 1 by n into n plus 1 will tell. What is this? N tend to infinity. So this tend to 0. Directly we can apply x to the power aj, this formula, a to the power x minus 1 by x log a. So x to the power this tend to 0. So this is coming log x. This is a to the power x minus 1 by x. This tend to 0. This formula here, that is log x or ln x, whatever you say, n cancel. So this n I am taking out, 1 by n. 1 by n is 0. So log x. So I'm leaving everybody. Bye everyone.